Attendees are in listen-only mode.
Hello everyone, and welcome to today's webinar on using automation in electrical safety testing. Today, November 12, 2014, this is our last webinar in our 2014 series of webinars, and I'm your host, I'm your presenter, Syed Abidi, presenting this one live from the Associated Research headquarters in Lake Forest, Illinois. Now, before we get into the real meat of our webinar, a few things to remember. Like always, we have a Q&A utility to ask us any questions concerning the material being presented. Also joining us today is our host, Jim Kennedy. Any questions related to running of the meeting, audio and visual, can be addressed to Jim through the chat line. This webinar is being recorded and will be available to view usually within a day or two. And also joining us is Mr. Peter Stevens, who's our domestic sales manager, very experienced with electrical safety testing applications, and he will be assisting us today with any questions that you guys may have on the, and you can use the chat line to ask those questions to Pete as well. Okay, so as you all know, we have been, this is the last webinar for 2014. We've covered various different topics and in quite a bit of detail. We've touched upon many different types of electrical safety tests, some specific applications regarding, and then some presentations on electrical safety. Today our topic is using automation in electrical safety testing. And as always, just a quick recap of the previous webinar, which was presented by my colleague Nick Pietrowski, and the topic for that one was safe workstation. And just to quickly go over and refresh your minds, if you were, if you did join our last webinar, you probably are aware of these things. But just to quickly overview, we covered safety, what is safety, some of the shock hazards and effects of current on the human body. We gave you some tips regarding, what a qualified test operator should know. And then we provided some examples of, work test stations with positive protection, stations without positive protection. And then we provided some more examples of, setting up safe test stations and some training resources. So that's what we covered during our last webinar. And today's webinar is, again, on using automation in electrical safety testing. And here's a quick recap or a quick snapshot of what we will be trying to cover. I don't anticipate this to go beyond 50 minutes, and then we'll leave some time open in the end for questions. So today I plan on going over, talking about some common electrical safety tests. Again, this will be a quick overview because we've covered these basic electrical safety test types in pretty much all our webinars except for a few, I think. And again, for those who were not able to join us in some of the previous webinars, this will be a good recap. Then we're going to talk about the real meat of this webinar, which is using automation and multi-point testing. So we'll try to cover, understand where the need for multi-point testing comes in, and how multiplexers or scanning matrices, scanners, can be used for, multi-point testing. We'll give some examples of multi-point testing And lastly, we will take it to the next level and add software control to basically set up a fully automated test system with minimizing operator intervention and again minimizing overall chance of operator error. We will give some advantages of using multiplexers, and along with the associated research, custom Autoware software, instrument control software. So having said that, let's go ahead and again real quick go over, again you guys are probably have seen this before many times, but just as a quick overview, why do we test a product? Well, there are four main basic reasons why. One is for safety. We have to ensure that our products are not going to pose a shock hazard to the end user once they're in the market. The next reason is quality. Of course, we want to make sure our there are no workmanship defects in our products, and prevent any faults from occurring once our products are out in the market. Cost control is another reason why we perform electrical safety tests, because we want to identify any problems before a product is shipped, and that way we can prevent costly recalls, product recalls. And lastly, for liability, you want to prevent product liability suits, because the responsibility of performing the electrical safety tests ultimately depends on the manufacturer. So here are the most important reasons, most common reasons why electrical safety testing is performed. So real quick, let's go over some of the basic electrical safety tests that we have covered many times in the past, but this again will be a quick overview, starting with the ground continuity test. Again, this is one of the most simplest of all the electrical safety tests. All it does is verifies a connection between the exposed conductive parts and the ground of the power cord on the product under test. Now, remember, we discussed Class 1 and Class 2 products as well in the past. The ground continuity test and the ground bond test that we're going to talk about next is only applicable for Class 1 products that do have a ground circuit in their power cord. How this test is performed, it's nothing more than applying a signal at one point of the circuit and measuring that signal on another point, and hence checking for continuity, seeing if the path is continuous. So that's the same concept that's applied for this test. A small low voltage AC or DC signal is applied from the chassis of the product to the ground pin, and that just is more than enough to verify that a ground connection exists and it is continuous. Okay, next, the ground bond test, very similar to a ground continuity test in the sense that it is also applicable for Class 1 products only that do have a ground pin or a ground connection. This test does a little more than the continuity test. It not just verifies the whether a ground circuit is continuous or not, but it basically additionally verifies the integrity of the ground connection between exposed metal and ground wire of the power cord. Basically, it tests or checks the integrity of the ground connection and tells us how good the ground connection is, and if it will be able to conduct any fault currents if there was a fault in our product. How the ground bond test is run? A high current. Now, unlike the continuity test where a small voltage, small current signal or pulse is sent, here a very high current is injected into the ground pin of the product's power cord, which flows through the chassis. This current usually is determined by the safety standard that you're trying to comply with, but usually it's twice the current rating of your product. That can change again based on the standard, and it determines if the safety ground wire is capable of handling excessive current flow in case a fault occurs and the product's insulation fails. So again, Pretty similar, if a ground bond test is being performed, there's no need for running a ground continuity test, because really ground bond test is also verifying the connection is continuous, and if the resistance of the ground connection is low enough to handle any fault currents imposed upon it. Here's a typical circuit. We've seen this before. For a ground bond test, high current is injected through the ground pin. On the left side, you can assume that to be the ground bond tester. Right side is the product being tested, and you can see the power cord with line, neutral, and ground. High current is injected through the ground pin, travels through the chassis of the product, and is measured through the return sensors of the instrument. And that gives us a reading usually in milliohms. And again, a low reading for the ground circuit is a good thing, and that would tell us that our ground connection is good enough to handle any fault currents, and it's low enough resistance. Next, one of the most common and most famous electrical safety tests is the dielectric voltage withstand test, also very commonly known as the Hipot, short for the word high potential. This test is used to determine whether the insulation of a product is able to withstand an overvoltage condition for a period of time without breaking down. It is basically a deliberate application of high voltage potential between the mains input of a product and any exposed dead metal, meaning that a high voltage is applied by shorting line for three-prong product, a class 1 product. The way Hipot test is performed is high voltage. Usually the high voltage is determined, again, by the standard you're trying to comply with, but a rule of thumb for determining Hipot voltage is twice the voltage rating of your product plus 1,000 volts. So for something that's run in the US at 120 volts, it comes out to be 1,240 or 1.24 kilovolts. That's how you would determine your Hipot voltage, unless it's it's stated differently by the standard you're trying to comply with, and that is the best way to determine your high voltage for your test parameters, is by thoroughly reading the standard. So the result of the application of high voltage potential between the mains input of a product, results in a leakage current. The resulting leakage current due to this application of high voltage is measured, and it's used to determine whether a product's insulation is able to withstand the high voltage without breaking down. This test verifies that the insulation of a product is capable of protecting the user from any leakage currents as a result of an electrical fault within the product. So this test, Hipot test, unlike the ground bond, ground continuity test, is stressing the insulation of a product and telling us how good the insulation is and whether it will break down if a high voltage over voltage condition is determined, is occurring. Here's a typical circuit for a high voltage. Again, we've shared this with you in a lot of previous webinars, but one last time this year, you guys are going to take a look at this circuit. And again, as you can see, on the left side is on the picture, we have the Omnia 2 model, Associated Research Electrical Safety Compliance Analyzer, and this is a 7-in-1 tester. As you can see, the white port, it's on the top, is where the high voltage is being applied from, and it's applied to the mains input of the product, usually by shorting line and neutral, and the resulting leakage is measured at the ground or the chassis of the product, and the resulting leakage gives us a good measure of how good the insulation is. This test is also very common because it's it gives us some information about a product that no other test can give, such as detecting possible defects in the design and of the product, and workmanship defects such as inadequate distance creepage and clearance distances between the current carrying conductors. Once again, we're not going to go in too much detail about Hipot test because we've dedicated two full webinars, Hipot 101, 102, just for Hipot testing. So if you do still feel that you need to learn more about Hipot testing, feel free to look at our webinar archive on our website, asresearch.com, and you will find a list of all the webinars that were recorded for 2014. Okay, lastly, the last test that we're going to quickly cover is the touch current test, also commonly known as the line leakage test. This test is performed on electrical products to measure the leakage current which could flow through a person while the product is operating. Now, this is the key word here because ground continuity test, ground bond test, or Hipot test, they are performed while the product is not being powered on. But the product is not functional while those tests are performed because they're basically testing the ground connection and the insulation of the product. Here, for the touch current or the line leakage test, the big difference is that the product is actually running as it would normally, and then the leakage current measurements are made. The measuring device is used for line leakage tests, which basically simulates the impedance of the human body under different conditions depending on the application of the product. This test is run under normal conditions and fault conditions. Could be single fault conditions, reverse polarity on the input line power, usually at 110% of the rated input. And again, the parameters, test parameters, the best resource for these are the safety standards that you are trying to comply with. Line leakage test is most commonly performed on medical equipment. However, we have seen applications where this test is performed on products that are not medical. Here's a typical circuit for a touch current test. The product being tested is on the right side of the picture. Left side is the line leakage or the touch current tester. As you can see, there's a few switches, S1, S2, and S3, and these are the switches that can simulate fault conditions on the input line. And opening and closing of these switches, setting these switches in a sequence can basically insert or simulate fault conditions that are possible during normal function of the product. Okay, so before we go into the real meat of this webinar, which is multi-point testing and automation, we'd like to do a quick poll. All of the tests that we have performed, that we've talked about in the past and just now in this webinar, are required to be performed at multiple different points on a product, especially when it comes to medical device testing. There are many patient connections, patient leads, applied parts that are required to be tested for all of the tests that we talked about, and that's why the need for multi-point testing comes in. And before we get into that, we'd like to do a quick poll. Jim Kennedy would run the poll real quick and ask you your opinion on a few things.
Hey Syed, it looks like 57% of the people here do perform multi-point testing and 43% do not.
All right, thanks a lot, Jim, for sharing the results. Okay, so we have First of all, thanks for participating in this poll. It gives us some really good feedback from you guys. And the result of the poll was, first of all, the question was, does your workstation incorporate multi-point testing? And the result was 57% yes, 43% no. So that's really good to know that a lot of people are performing, and as we expected, a lot of people are performing multi-point testing. So let's talk about multi-point testing. As we know, recent advances in electrical safety testing technology have made complying with safety agency standards far easier and more efficient for electrical product manufacturers. And from appliances to medical devices, most electrically powered products must comply with safety standards that specify some combination of Hipot, ground bond, insulation resistance, and touch current tests. In fact, more advanced applications not only require these tests, but also specify that they be performed at multiple points on a product's chassis, and therefore hence the need for multi-point testing. The nature of multi-point testing is, it can drastically increase setup time, contribute to operator errors, and reduce production efficiency. And as we know, until recently, test operators were forced to, change connections and rewire test leads in between each test. All the negative aspects of multi-point testing can be eliminated by using a scanning matrix, which we are going to talk about shortly. But so the need for multi-point testing, can lead to reduced test times, decrease the risk of operator error, and increase or provide more operator safety, because if you're running a multi-point test, you would not want your operator to intervene the test, test setup, change test leads after every step or after every single point is being tested. Therefore, the need for multi-point testing gives rise to using multiplexers. Now, what are multiplexers? Associated Research's answer for multi-point testing is the model SC6540 scanning matrix. Well, this basically is the scanning matrix. The SC6540 is nothing but these are instruments that act as high voltage and high current relay switch boxes. These types of devices basically take the output of a piece of test instrument. It could be a Hipot tester, ground bond tester, or any other type of electrical safety tester, and apply it to different points on the device under test without the need for additional connections or rewiring. So this is how it eliminates operator intervention for multi-point testing. By providing all of the necessary relays inside the instrument, the test operators no longer need to manually change test connections in between test steps. So therefore, these now again, the word multiplexers or scanning matrices and scanners basically refer to the same thing. Scanning matrices can help to increase the throughput on the production line, because the test operator need only configure the test instrument and the scanner once prior to testing, meaning that all the test points that need to be tested for various tests can be connected to the different scanner channels, and the operator will not have to configure test cables between test steps. This, as you know, will save time, as the test routine does not need to stop in order for the test operator to manually change the test connections from one test to another. Scanning matrices also increase operator safety and minimize damage to the device being tested. Since the operators are no longer required to change the test leads during testing or in between test steps, the chance of incorrectly wiring the test leads, is eliminated. Hence, decreasing the leading cause of injury or, damage to the device being tested. The Associated Research SC6540 scanning matrix is a modular scanning matrix, meaning that it can be, multiple scanning matrices can be connected to each other to, to test, almost infinite number of points. These scanning matrices, can come up to 16 high voltage or high current channels in a convenient 2U design, which is the most commonly used these days. These scanning matrices can become customized in many different configurations for multi-point high-pot ground bond installation and touch current testing. The bottom of this slide, you'll see the picture of how the scanning matrix looks like. This is the front part showing multiple LEDs, and these, visually you can, the user is able to see which channels are set to the high side or the low side, or which ones are just left open. These scanning matrices can work with most of Associated Research safety test instruments, and they're compatible with, they come in different configurations, master and slave, which we'll talk about next, and they can be controlled using the test instrument itself or a PC program, an automated setup. Basically, scanning matrices can be also be located external or internal to the safety tester itself. It can, so meaning that you can purchase an electrical safety tester, for example, a Hipot tester, and you can have the option of having an internal scanner, meaning you don't have to have an external unit to go with if you're if you're wanting to run multi-point Hipot testing. You don't have to buy an extra box. You can have the scanner built into your safety tester. Internal scanning matrices are usually included as an option on certain types of testers, while the external scanners are sold separately in standalone chassis. Automation capability is also another means of classifying scanning matrices, as some are controlled directly from the front panel of the testing instrument, while others can be controlled by a PC. And internal, external, and automation-ready scanning matrices have advantages that depend on the application for which the instrument is being used. So, if you look at the table on this slide, you'll see the different configurations. You can, the SC6540 can be configured. It could be just 16 high voltage channels, 8 high voltage, 8 high current, which is the same as ground bond, or just 8 high voltage, just 16 ground bond channels, or just 8 ground bond channels or ports. Here's the backside view of the SC6540 that we've been talking about, and as you can see, the two different configurations are the master and slave. So each of the previous configurations that we saw can also be either a master or a slave configuration, meaning that a master's configuration, as you can see from the picture, it has its own power module, and it has serial capability to be connected to a PC. In fact, a master scanner has to it has to be connected to a PC to be controlled. AR's instruments can only control slave configuration scanners, and for example, some safety testing equipment such as the Associated Research Model 7650, it can include a built-in scanning matrix for easy multi-point Hipot and installation resistance testing, or it can have control its external slave scanner. But if more test points are needed, there's always the option of getting a master scanner being controlled by some kind of software, and the master scanner can basically control 3 slaves. So you can imagine how many test points you can have that way. Here's a quick or just a real real life example of how scanners can be set up. In this picture, this is just of course the back view of the entire test system, and as you can see at the very bottom we have a power source. On top of that we have the Associated Research Omnia 2 model, which is the complete electrical safety compliance analyzer, and on top of that we have 2 scanners. And as we saw, the one at the bottom is the master scanner because it has the serial capability and its own power module, and then it's controlling a slave scanner on top. This could very well have had 2 more slave scanners, which the master scanner can control. And as you can see, how I talked about, how these scanners are just basically instruments that act as high voltage and high current relay switch boxes. High voltage and high current is being routed from the safety analyzer into the scanning matrices, and then controlling these scanner channels can route that high current or high voltage to different channels, different parts, and those channels can be connected to different applied parts or points on your device that's being tested, hence allowing our users to run multi-point testing on their products. So, for example, on a SC6540 model, with the 8 high voltage channels, they can be configured either from the front panel of the instrument or through software, and that this allows the test operators to apply high voltage between multiple points quickly and easily without the need to purchase any additional equipment. An electrical safety testing instrument with an internal scanning matrix is basically a much more cost-effective solution for manufacturers with the need for multi-point testing applications who wish to increase productivity and improve safety. But again, if there's a need for adding more channels or more test points, using external boxes is an option, and using a master-slave configuration can, basically allow you to test, an infinite number of test points. Here's another quick example of how connections, how an external scanner can be connected to Associated Research Model Omnia 2. And as you can see, the high current, the returns, the high voltage can all be routed from the instrument, which is on the top of the picture, into the scanner and distributed to different channels based on this application. Now, some electrical safety testing equipment may not include an internal scanner, but can be configured to operate one. For again, the example that we're looking at right now shows the Associated Research Model Omnia 2 model, and the SC6540 in the bottom can be configured from the front panel of the test instrument or through software. But when used together, the test instrument and the external scanning matrix make test setup quick and easy and reduce the chance of operator error or injury. And an electrical safety testing instrument and and an external matrix is an ideal solution for appliance or medical device manufacturers Why? Because on medical devices, usually there are multiple test points or patient needs applied parts that need to be tested, that are called out by the standards, safety standards, to be tested. So this provides a solution for, a great solution for medical appliances, and that are required to perform multiple safety tests at different points on each product. To take it, multiplexers can also, be, like I said, controlled using automation, and we'll talk about that next. But some of the advantages of using multiplexers comes from the fact that for manufacturers with complex test routines, the benefits of using a scanning matrix don't end with direct front panel control. Indeed, automated test routines that utilize both an electrical safety testing instrument and an accompanying scanning matrix are an economical solution that increases production efficiency, it reduces the risk of operator error or damage to the device, and can improve performance exponentially. Most safety testing equipment providers realize that manufacturers' workplace requirements and skill sets vary. This is why models like the Associated Research SC6540 can be configured to work with a PC and any number of automation interfaces, which includes GPIB, RS-232, and USB, which we'll talk about more once we move towards talking about automation. Available software packages such as the Associated Research's Autoware program can make controlling the instrument and the accompanying scanning matrix quick and easy. It allows the test operator to configure multiple test routines, execute them, and store the test results on a PC or a local network. So in addition to using multiplexers for multi-point testing, we can take it to the next level, and for setting up a fully automated test system by using a control software that can allow users to set up a fully automated test system. Now, as we all know, there are many types of instrument control software available, but Associated Research has come up with their own software, custom software, which is called the Autoware software, and it is unique in many different ways. First of all, this custom software allows full control of the test equipment and has the capability to record and log test data, test results, print direct test reports with various filters, and provide a very user-friendly interface. And again, we will do a quick demo of the Autoware 2 software, which is one of the software that Associated Research developed for controlling some of its test analyzers, such as the Omnia 2 and the scanning matrices. Autoware 2 comes in many different configurations, and it depending on the model of the test instrument being used. It is a licensed software with a security and user profiles which is perfect for lab or production line testing. Now, most of the Associated Research models are available in many different communication interfaces, and we just talked about that. Serial, which is USB, RS-232, GPIB, and Ethernet. And Autoware is compatible with all of these communication interfaces, meaning that you can have any of these communication interfaces on your test instrument and still be able to use Autoware software to control your test equipment. In addition to providing full control of the instruments, the Autoware software has some additional features to make testing further simplifying testing and making it easier for the users. And we will look at all that once we move towards the demo of our software. And we have a lot of training material and support available for our custom Autoware software, and it is basically a free trial version of the software is also available through our website for you to play around with it and see if it fits your needs, if it is the right tool for your electrical safety testing. Feel free to utilize this free trial version, and it gives you full control of your instrument, and it has a demo version which basically you don't need to connect to an instrument. You can just play around with it to familiarize yourself with the capabilities of the software, and it will simulate an actual test scenario even in the demo mode. And so basically combining test equipments with multiplexers and controlling all the test equipment by a custom software such as Autoware, it basically can allow you to form or develop a fully automated test system. A fully automated test system meaning that all you need to do is at the beginning of your test make all the necessary connections, and then you can be sitting far away from the actual test instrument and running the test using the Autoware software, collecting data, analyzing data. You can transfer or export data to Excel files and etc. It allows you to print reports, use various filters to control your test reports, and overall it's a perfect system for if you're looking for a fully automated test setup. So before we move forward, we would like to do another poll and take a short few seconds break, and Jim will just get the poll ready.
Hi, Syed. It looks like we have 40%.
Okay, we will continue with our material here. I think we were having some audio issues, so I don't think I heard Jim very well. But we will give out the poll results pretty soon. The question was, does your workstation incorporate instrument control software? And I think all I heard was 40% of you guys answered yes, I believe. However, we will continue with our presentation here. So here's a quick snap. Well, okay, before we go into that, I think I have the poll results, and 40%, as I heard, said yes, and 60% said no. And that is again a very expected result, because automation is usually used in in production environment, in high volume production environments, and especially in the medical device testing. So thanks for participating in the poll. Here's a quick snapshot of the Autoware instrument control software. This is the Autoware 2 software, which is capable of controlling multiple different instruments, including the Omnia. As you can see, right now we're taking a look at the system settings screen, where you can see that you can see all the instruments that are being detected by the software. The one that I've checked is the demo that I basically added to the screen, and I guess the best way to do a quick demo of the Autoware software is by actually running the software in the background, so that you guys can take a look and see how things can be set up. So here is what I was trying to show you guys earlier, and this is the same screen, but now this is the actual software running on my PC. And as you can see, right now, due to the capability of Ethernet, GPIB, serial, we can see some of the instruments, such as the Omnia 8257 is showing an IP address, meaning that this instrument is connected via the Ethernet, and I can control it pretty much from anywhere in the world. So that's a big advantage of having Ethernet communication. However, what we're going to do here is that first we're going to look at the software options and to talk about some of the additional features Autoware brings in and allows the user to safely run their tests. And this is the software options screen. As you can see, there's a check mark for security. This allows you to add or different users and assign different user settings, and the next one that's checked is the LLT autofill, a very important feature. As you know, for the touch current testing, there's many different scenarios that the medical device industry guys like to test. This option allows basically instead of them setting each and every fault condition manually, this basically populates all those different types of tests for the user. So that saves a lot of time. You also have a batch test feature right here, a very important feature if you're trying to test multiple products at the same time. As you can see, we also have the barcode model selection settings in our software, and this is again a feature that comes in very handy for high volume production testing. All you need to do is scan a barcode, make the necessary settings, scan the barcode, and the correct test file will be loaded in the control panel, and allowing the user to just execute the test from the control panel without loading, manually loading the test file. So having said that, we're going to go back to the system settings screen real quick, and once I double click on this, it's going to open up the configuration screen for the instrument. Right now we're in the demo mode, but if I was actually connected to an instrument, this would say, depending on what kind of interface I was using, it would say either Ethernet, serial, or GPIB, but we're going to leave it as demo for now. A list of instruments that can be connected right now. Right now we're connected to an Omnia 8206, which is a AC/DC Hipot tester, insular resistance tester, ground continuity, ground bond, and line leakage and functional run tester. Some features like the Smart GFI PLC control can also be set from this window, and down at the bottom you can also look at the different options that are available in your instrument. These are all the options that are available in your instrument that you probably have purchased or are activated in your instrument. And as you can see, I'm going to simulate an Omnia 8206 with an internal 8-port scanner, which is why I have this clicked right here, and I have a 1x8 channel scanner. So we're going to click OK here, and we're going to move to our test manager window. Here is where you actually can set up your test file and add test steps, including prompt messages. So I've already created a test file which I'm calling Syed, and what I'm going to quickly do is I'm going to first I don't know how this happened, but okay, we're going to start adding some tests. So once I have created a test file, the way I did that was by clicking on the create file button, and then I'll just enter my name or whatever the test file I want to name and click OK. It'll show up here in this column under the PC folder, and then I can just start adding different tests. So I'll start with the continuity tests, and as you can see, once you click on the test type, the new window will pop up, and you can set your test parameters just as you would do using the front panel of the instrument. And at the bottom, you can set your scanner channels. So if I want to test for I've connected one point of my product on channel 1 of the scanner and the other point on channel 3, I can test for continuity between 1 and 3 by setting the appropriate channels to the high side or the low side and leaving the rest open or off. So I can press OK. As you can see, the first test was a continuity test, has been added to my list of tests under this Syed.tsf test file. Next test, just for fun, I'm going to add a AC withstand test, and again, a new window will pop up. You can set your voltage, your current limits. Right now, we're in the demo mode, so I'm not too worried about the parameters, but what I really wanted to show you guys is that this is all the information that you will see on the, if you were using this instrument from just the front panel. This is everything you'll see, plus some additional features. So here is how the AC withstand test parameters look. Another feature that you can use is if you want to give a description to each of the step within your test file, each of the test step, you can click on this test description bar here and type in whatever you want to type. And you can also click on the scanner settings, and that would take you to just another page where you can do the same setup that you could do here. In some cases, if you have additional scanner channels, this room may not be enough, so you can click on the scanner settings and that'll show you all your scanner channels. So for now, we're just going to stick with just these two tests for our demo purpose, and we're going to hit save to make sure that our test settings, our test steps that we added to this test file are saved. And right when I move to the control panel, this is where I should be able to run my tests. As you can see, this is a slightly different screen, and once I go back here, now I am ready to execute my test. Now I know I've already set my connections, my test cables, scanners, whatever is involved in my setup, everything is already done, and all I need to do at this point is to click the test. However, if I was using barcode scanning, I could just scan my barcode and the correct test file would already load up in this window. All I need to do next is click the test button. As you can see, the test will start to execute. You'll see the test, the different phases of the test. These are very 1 second tests, and so that ends the test sequence, which included a continuity test and an AC withstand test. The next thing we're going to do is quickly look at the results, and if I click on last, here is what I was talking about, how Autoware 2 allows the users to look at the test results and apply various filters. As you can see here, there's filters here that you can apply. You can just look at the passes, just the fails, just the test types. You could filter the results by operator, who ran it, multiple different features. We don't have the time to go in all that detail, but I would highly encourage you guys, if you are interested in automation, Autoware 2 is one of the is a very unique software instrument control program, and feel free to download a free copy, free trial version, and play around with it, familiarize yourself with it. So here's how the results screen look. There's an export button. You can specify the path to where you want to export these results, and you could do that as well. The next thing is the print report. This is again, you can print this test report by, apply some filters to it. Not as many as the results window had, but as you can see, pass, fail, or all, and then you can have this report printed directly to a printer or a PDF. It really depends. You can configure your, if you click on select printer, this is where you can configure the printer, and once everything is set, all the filters are set, you can hit the print button. It will print a copy on PDF or on a piece of paper that is depending on the printer that's connected. You can also select between different report types. This is the advanced report type. As you can see here, you can see a few extra parameters. The big difference here is that you can see your test setup parameters as well as your test results, whereas the standard test report just shows you your test results. So that was a quick overview of what how Autoware 2 can be used for along with scanners and test instruments to form a fully automated test setup. And that sort of brings us to the end of our presentation here, and we will, again, these are just snapshots of what we just saw. We did a live demo instead of just showing you some pictures. At the end, I would just, quickly summarize what we just talked about in today's webinar. And as we know, there are software packages available such as AR's Autoware program that make controlling the instrument and the accompanying scanning matrix quick and easy. Another unique benefit of the scanning matrix, and the Autoware is basically, setting up the modular feature of the scanners is a very important feature if you want to have many different test points, and they can be controlled as a system using the Autoware software. Scanning matrices are an ideal solution for multi-point testing applications. And as we know, with a multitude of optional topologies that are available, it has never been easier for a manufacturer to select the ideal instrument or the scanning matrix combination for the job. Whether it's an internal or external, locally controlled or automated, incorporating a scanning matrix into your electrical safety testing routine and controlling it using Autoware software will basically provide big benefits in productivity and safety. So that concludes our presentation for today. We will now leave some time open for any questions that you may have. Feel free to use the chat line for those questions. And in the end, I would like to thank all of you for joining us today, and for all our previous webinars. As you know, this was the last webinar in our 2014 series of webinars. We will take a couple of months break, and we will be back in 2015, and our schedule for 2015 will be up shortly on our website. And if you would like a copy of this presentation, contact Jim Kennedy at jimk@asresearch.com. Check out our website at asresearch.com. Follow us on YouTube, Twitter, LinkedIn, using the links shown on the screen. Again, it's been a pleasure presenting these webinars, and I hope you guys have benefited from these. And we're looking forward to having you guys join us again next year for a fresh round of presentations. In the meanwhile, if you have any questions, yeah, go ahead.
Yes, Syed, actually, there is one question here.
Mhm.
Actually, I got a couple of questions here. First one is there any way to lock out operators from making changes? I'm assuming that has to do more with the software than it does the scanner.
Correct. Okay. So that was a good question. Yes, the security feature on the Autoware software is what allows to give permissions to different users. So you can add a user and give that user just enough access to be able to execute the test that you have already set up. So the user cannot go in and change any settings on your test. That includes scanner settings, test parameters, test types.
And Syed, I got one more, just real quick one, just
Sure.
in reference to the scanners themselves. Are there any calibration or service requirements for that instrument?
Okay. Again, we had a question from one of you guys for calibration and service requirements. Yes, we do recommend getting your instruments, including scanners, calibrated. You want to make sure your scanners are working within the specified range and are working according to the specs. So it is always a good idea to have these instruments inspected and calibrated yearly. If there are no more questions, we would like to end this session. And once again, we will miss you for a few months, but we will be back next year. So till then, you guys have great holidays, and we'll see you soon. Thanks a lot.